Hi, in this video I will talk about break-even analysis between two alternatives. Consider that we have two mutually exclusive alternatives with linear cost relations. Alright, so the first line represents the total cost for alternative 1. It has a lower fixed cost but higher variable cost because of the line has higher slope. And for the second alternative, the alternative has a higher fixed cost, but the variable cost is lower because of the line has lower slope. The intersection of these two lines will give us the break-even point. This is the point at which the two alternatives are equals, or the two alternatives have the same cost. So given this graph, we're gonna make a selection based on the following criteria. Okay. So if we are given the amount below the break-even value, we're going to select the alternative with higher variable cost because this alternative has lower total cost. But if we are given the amount above the break-even point, so we're going to select the alternative with lower variable cost because this alternative has lower total cost. Okay, let's look at an example. An irrigation canal contractor wants to determine whether he should purchase a used Caterpillar mini excavator or a Toro-powered rotary tiller for servicing irrigation ditches in an agricultural area of Tanjung Batu, Melaka. So the initial cost of the excavator is 26,500 ringgit with a 9,000 ringgit of salvage value after 10 years. Fixed costs for insurance, license, etc. are expected to be 18,000 per year. The excavator will require one operator at 15 per hour and maintenance at 1 ringgit per hour. So in 1 hour, 0.15 mile of ditch can be repaired. For alternative 2, the contractor can purchase a tiller and hire two workers at 11 ringgit per hour each. The tiller costs 1,200 and has a useful life of 5 years with no salvage value. Its operating cost is expected to be 1 ringgit and 20 cent per hour, and with the tiller, the two workers can prepare 0.04 mile of ditch in 1 hour. The contractor's MAR is 10% per year. So analyze with graph the number of miles of ditch per year the contractor would have to service for the two options to break even. So the question is actually asking you to find the number of miles of ditch per year that these two options break even. Okay, so we are interested find the quantity of break even and we're gonna let X to represent the miles of ditch per year for the break even quantity. So this is the information given for the excavator, right? Remember that we are interested to find the number of miles of ditch per year. So the first thing that we want to do is to find the variable cost, which is the cost per mile. Okay, so how do we find the cost per mile? The reason we want to find the cost per mile so that we can get the annual variable cost for related to the cost per mile. So we're gonna add the 15 ringgit with 1 ringgit for the operator and maintenance cost, which is the cost per hour, and divided by 0.15 months. This will give us 106 ringgit and 67 cent mile per sorry, this will give us 106 and 67 ringgit per mile, which is the cost per mile. So now let's find the annual worth of this alternative, right? So first we are given the initial cost, and because this is a present value, we're going to convert to annual worth by multiplying with the factor of A given P, 10%, and because of we are interested to find the annual worth over 10 years, which is the useful life of this excavator, we put the 10 as the number of period. Okay, and then minus 18,000, which is the cost, the fixed cost per year. And this is already annual value, so we don't have to convert anymore to a different value, right? And next, we're gonna add with the salvage value, which is the future value. So we're gonna multiply this value with the factor of find A given F, 10% and N equals to 10. Okay, because this is a future value at year 10 and the annual worth that we are interested in is over 10 period. Okay. So this gives us the fixed annual worth for fixed cost. We have to add with the variable cost, which is minus 106.67 multiply with the x quantity. Okay, so then we will get this value, and for the tiller, given this information, we can first also calculate the variable cost, which is the cost per mile, and this can be obtained by adding one ringgit and 20 cent with the worker rate, which is 11 ringgit per hour, but we have to multiply with 2 because this tiller requires 2 operators, okay, to operate, and we divide this quantity of rate per hour with the number of miles prepared in 1 hour, which is 0.05, 0.04 mile, and we get 580 ringgit per mile as the cost per mile. Now we can calculate the annual worth of tiller alternative, right? So the first cost is 1200 and we have to convert this present value into annual worth. So we multiply with factor of A given P, okay, 10% and N equals to 5 because the useful life is 5 years, because this is the only fixed cost actually for the tiller. So we're gonna add the variable cost, the annual variable cost, which is 580 ringgit, okay, the cost per mile multiply with the number of miles per year, okay. So we have this value, and next we're going to equate the two value that we just obtained, okay, for the two alternative, and we get this equation. Now we can rearrange this equation and solve for x. That will give us x equals to 45.3 miles per year. Okay, this is the break-even quantity for this problem. Okay, 45.3 miles per year. So now let's draw the graph for this analysis. Okay, consider that we have the cost against the number of miles. So the first alternative is excavator. It has a it has fixed cost of 316.53. Okay, and the second alternative is tiller with a fixed cost of 21,748. So the intersection of these two lines will give us the break-even quantity, and we already calculated the break-even quantity, which is 45.3. Okay, so based on this graph, how do we analyze this problem? So if the number of miles of ditch that you're going to work for is higher than the break-even quantity, you are going to choose tiller. Okay, so in this region, you're going to choose tiller because it has lower total cost, which is also the alternative with lower variable cost. But if the number of miles that you're going to work for is less than the break-even quantity, so you're going to choose uh, excavator because it has lower total cost below the break-even quantity, which also means that excavator has higher variable cost. Okay, that's all for this video. Thank you.